Welcome back to our IB Physics video series. This is the third video in IB Physics topic 5, electricity and magnetism, where we will be looking at circuits, Kirchhoff's law, and circuit calculations. All our knowledge surrounding voltage, current, resistance, and power culminates in the creation of circuits. We commonly know them as wiring in houses or electrical components, but the definition is simply the path current flows. Let's cover the basic circuit you need to know for your IB exam, which typically consists of three components: a power supply, wire, and array of components. A power supply produces the voltage that induces a current. This is symbolized with a long line to indicate the positive terminal and a short line to indicate the negative terminal. A loop of wire is connected to the power supply, wherein current flows from the positive to the negative terminal. Components can take many forms, and they provide resistance. The most common component is the resistor, and we will explore more in our next video. There are two main states of any circuit, open and closed. These utilize a switch that breaks or completes the loop of wire. In an open circuit, the loop is broken, and thus there is no flow of current. In a closed circuit, the loop is complete, and thus current can flow. In more complex branch circuits, there might be multiple switches. Note that in these, current only flows through the completed loop. The way in which components are arranged changes the resistance of the circuit. Let's cover the two types of circuits you need to know for your exam, created by differing component arrangement: series and parallel. A series circuit aligns components in one continuous loop. In this circuit, the total resistance of the circuit equals the sum of the resistances of the components. In this example circuit with 1 kiloohm, 3 kiloohm and 6 kiloohm resistors, the total resistance is 1 plus 3 plus 6, so 10 kiloohms. A parallel circuit aligns components in branches parallel to one another. In this circuit, the inverse total resistance of the circuit equals the sum of the inverse resistances of the components. In this example circuit with 1 kiloohm, 3 kiloohm and 6 kiloohm resistors, the inverse resistance is 1 over 1 plus 1/3 plus 1/6. Rephrased as 6/6, 2/6, and 1/6, so 9/6. Flipping this over, the total resistance is 6/9 kiloohms, i.e. 0.67 kiloohms. An exam trick is that if all the components have the same resistance, the total resistance of the circuit is the resistance divided by the number of branches. So, if in the previous circuit all resistors had a resistance of 3 kiloohms across 3 branches, the total resistance of the circuit is 1 kiloohm. However, common exam questions focus not on resistance, but current and voltage. Typically, they will ask you to analyze individual components or branches of a circuit with respect to these factors. This is defined by Kirchhoff's law. There are two Kirchhoff laws that you need to know, relating current and voltage respectively. Kirchhoff's first law states that at any junction, the sum of all incoming currents is 0. To explain this, we can imagine a circuit which divides into two branches, representing the current before the junction as A and the current after as B and C. The law states that A subtract B subtract C equals 0, and by extension, A equals B plus C. It can therefore be said that incoming current equals outgoing current. For example, if A was 12 amp, B and C could be any combination that summates to 12. i.e. 8 and 4, or 6 and 6 respectively. Note the current that divides into each branch is inverse to the resistance, i.e. higher resistance branches have less current. You can remember this with the saying, current flows the path of least resistance. For example, if the top branch has resistance 1 kiloohm and the bottom 2 kiloohm, the top takes 2/3 of the current and the bottom 1/3. In our example, this would calculate as 8 amp and 4 amp respectively. Kirchhoff's second law states that in any loop, the sum of all voltages across components and power supplies is 0. Let's imagine a circuit with 3 bulbs contained within. We could represent the voltage across the bulbs as A, B, and C. Kirchhoff's second law states that A plus B plus C equals total voltage. This is simplified to voltage provided equals voltage used. So, if the battery provides 6 volts, the voltage used by all 3 bulbs would be 6 volts. Note that the voltage across each component is proportional to the resistance, i.e. higher resistance components use more voltage. For example, if the bulbs had resistance of 1 kΩ, 2 kΩ and 3 kΩ, their voltages used would be 1 volt, 2 volt and 3 volt respectively.
You've now reached the end of the preview for this IB Science video. If you want to check out the full video, head over to our website and select a membership plan today.